All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 122 is on the screen. By now, you guys are experts at that, so I'll give you some time to complete that, and then we're moving on. Get a Cornell note ready. Also get 4 coordinate planes from -10 to 10 ready as well. We're moving on. Let's go. Bye. All right, looks like we're almost done, and we're going to have Anthony get us started with number 1, since we're almost completely done with that warm-up. And then number 2, Anthony's probably going to pass it to Jay. And looks like Ryland's got number 3. Ryland, number 3. And number 4, what do you think, Ryland? Who would you pass that to? Yeah. To me? All right, so Ryland's doing number 4 as well. All right. 3 and 4. All right, let's start with number 1. We got Anthony E. F of x equals 2 to the x minus 2, but now we got f of -3. What'd you get for that, Anthony E? Okay, I'll come back to you. So Anthony D is going to enlighten us now with f of x equals 10 to the x minus 1, and we're starting with f of -3. What'd you get to f of -3 now with base 10? Ten to the exponent of -4, because we substituted -3 right there. All right. Ooh, so far so good. Hold on, I have it frozen, sorry. So 10 to the power of 4, 10 over to the power of 4, hold on. And what does that become? Let's go. Hands, have you got that? Okay, good. So, for the sake of time, you should know what to do with the other 2. I'm not going to go over that process. I just wanted to show you the process for that. However, we still have f of -3 for the base 2. What'd you get, Anthony E? Exponent 5. And that becomes 1 over 2 times 2 times 2 times 2 times 2, which is 64. And have you got that? All right, good. All right, J, number 2. If we graph the parent function, f of x equals x squared, which is right there, what does this do to that? Up 3. To the right 4. Stretches it. That is correct. So first we stretch it. And then 4 to the right, 3 up. So it's going to be somewhere right there. And if you got something like that, that is correct. Or in other words, my new vertex for this one is what? Tell your neighbor, please. What is our new vertex for that? What is our new vertex? Emily P. 4, 3. That is correct. 4 steps to the right, 3 up. So our new vertex is at 4, 3. Thank you. All right, let's see. Who has number 3? Ryland. All right, here we go. 8 to the -6 becomes 1 over 8 to the 6. 50 to the 0 is 1. That is correct. Distribute the exponent here and here. That should have given you 1 to the negative 2 over 5 to the negative 2 and y to the negative 2. Therefore, what did this become, Rylan? You said 5 squared y squared over 1. Yeah, because these negatives go up here to make it a positive. This one goes down here. But are we done? No, this is what? Over 1, or we can leave it like that. That is correct. Let's go. All right. Since you're in a row, what does this become, Rylan? What's that? Give me the process. Which is? Let's go. Rylan in the house. All right. That is correct. Copy the agenda, please. Warm up 122, rational functions. Home plate for tonight, 6 transformations. 6 transformations. All right. Play code. Home plate code. NF647. 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 Now, once again, as we are finishing up the school year, make sure you stay up on top of your work. I'm getting ready to hand out your study guide for our final, semester final, which is coming up, I want to say in a couple of weeks. Also, we still need to check your notes or binder check, right? Yes, Mr. Q. So you should have all the warm-ups for the second semester and all your sessions or lessons, okay? All right? So, with that said, last week, I think the last home plate was this one. I don't know if I picked it up. I'm going to check later on Canvas. This is tonight. So, get a Cornell note ready, and you should have 4 coordinate planes ready from negative 10 to 10. Hands if you need more time to finish those up. Okay, I'll give you a couple more minutes. Get those ready, please. Our objective for today, I can write, solve, and graph rational functions. So we started with these already last week. We should be able to finish these this week. Remind your neighbor of the definition for rational functions. Definition. Very good. Functions or equations that contain one or more rational expressions. There they are. We started with simple steps to graph. Then from there we went from graphing to writing. We went from our general rule to our rational rule. And what does h do to the entire function, everyone, aside from the asymptote? It moves it from what? Left or right? How about k? Up and down. How about a? Stretch or compress, yes. And b, same thing, stretch or compress horizontally. We talked about asymptotes, and we're right now in the middle of vertical and horizontal. We covered these. Yes? We cover these. We need to do the division, long division for those. Then we went to writing an equation from the graph. And then we arrived here. I left you guys a video lesson that had these, but I'm going to go over this one more time just to make sure we got it. Writing utensils down, look up to the screen. So if I was to graph this, once again, the graph for this one looks like this. First, I need my asymptotes. Look up to the screen. Writing utensils down. Just pay attention. my VA, my HA, there they are. VA, X equals 0. HA, Y equals 0. You're just paying attention right now. And according to the instructions that I left you, we still use 1, 1. But what we saw in the video, that this one had a what different from the other ones? A squared. Is that correct? So instead of having the other point at -1, -1, it was at -1, 1. That's the graph. And I call these J-Lo. J-Lo. J and L. You guys see it? Yes? All right. And according to the video, we can use this as transformations as well. So, right now there's nothing next to the X, so that means it doesn't move anywhere, and there's nothing for the K. But what if I gave you this? My X, but now I put the minus, and I do 6, and then at the end I put plus 4, and then the little square. So, look at it, and remind your neighbor what's going to happen to this entire function. What is going to happen to that entire function according to that? Talk to your neighbor, please. Then Anthony's going to enlighten us. All right, Anthony E., go. What's going to happen to this one according to this? Help him out, Danny. 4 up. What else? 6 to the right. That is correct. So I take this entire thing, look up to the screen, and you're not copying anything. You already have this. And I'm going to move 6 to the right, 4 up. So I'm going to move this center right here, 1, 2, 3, 4, 5, 6. 4 up, 1, 2, 3, 4. And it should end up right there. You guys see it? Hands if you see it. All right. Not bad, not bad. Okay. However, what if I gave you, instead of that, let's see. What if I did this? Plus. Hold on, give me a second. All right, here we go. How about plus 5 and minus 6? Tell your neighbor we're going to move this parent function, f of x equals 1 over x squared, according to that. All right, looks like Maya's got it. Jazzy's got it. Very good, Jazzy. All right. So, before I move it, tell your neighbor what's our new VA and our new HA. VA and HA. Then Jazzy and Maya are going to enlighten us. Tell your neighbor our new VA and our new HA. New VA, new HA. Mute that. What's our new VA, Jazzy? -5. What did I do red on that one? -5. That is correct. And Maya, our new HA, -6. So we got -6, -5. So that means we're going to move it in which direction, Anthony E? Left and down. That is correct. So let's see If it's correct, then we're going to land with our VA at -5 and our HA at -6. Let me move the whole thing. Here it goes. So 5 to the left, so we go 1, 2, 3, 4, 5, and 6 down. 1, 2, 3, 4, 5, 6. You guys see it? Yes? And we should end up down there. All right, I'm not going to move it because I want to leave the original there. So that's how it went. All right? So from 1 to 5, I'll come to you with transformations now with the squared. All right, we good. So on your first coordinate plane, copy this one. Here we go. G of x equals 1 over x minus 5 squared. G of x equals 1 over x minus 5 squared. So, first things first, before you graph that, you need to graph the parent function f of x equals 1 over x squared. Remind your neighbor what to do for graphing that one. Make sure they know what to do. So our VA is x equals 0, HA y equals 0, so y equals 0 is right there. X equals 0. So tell me what points to use for my parent function, Brandon Doherty. For this, right now we're graphing this one. -1, 1. And 1, 1. Okay. So we're done with that. So now we need to graph this one. Tell your neighbor what you got for your new VA and your new HA. And then we're going to pass it to Rebecca and Jaylene over here. See how they do with that. Tell your neighbor what you got for that. Or maybe we go back to Anthony. How about that? Ooh, seems to be on the ball. Not even distracted at all with his cell phone. My goodness. Yeah, my peripherals are at 200%. Let's go. Magic Johnson. Huh, Jake? All right, all right. How's Potter Puff coming? Let's go. We got this. All right. Rebecca, our new VA. X equals 5. Jaylene, y equals 0. That is correct. So let's graph our y 0 again. I'm going to make it a little bit thicker so you can see that it's there. But now x equals 5 is over here. And now we need 2 points. Tell your neighbor what 2 points to use for the new transformed function. And we're going to pass it to Claire and Mitos. New 2 points. New 2 points. What are my new 2 points? Give us 1 point, Claire. 6, 1. That is correct. 6, 1 is correct. How about another one, Mitos? 4, 1. That is correct as well. Woo-wee. Man, you guys remind me of me in kindergarten. Let's go. Be nice, Claire. All right. From 1 to 5, how comfortable are you with that so far? Yeah, we got this, yes? You're like, Q, just bring on the pop party. Let's go. All right. Copy this next one, please. Example 3 mega cube. G of x equals negative 1 over x plus 6 squared minus 3. So we go to the next coordinate plane. Remember, start by graphing though. F of x equals 1 over x squared, and then move it according to this. I'll give you a head start. See how you do with that. Go. So once again, just going back to this one, remember, what's the only thing that needs to stay in the numerator? A 1. So anything else goes to the front. So in this case was a negative. From there, Maya said we're going 6 to the left and 3 down. Jazzy said our VA was x equals negative 1, y equals negative 3. So here it is. I asked Jay if we move these, where would they be now according to the mu? He said negative 5, negative 2, and negative 7, negative 2. That would be correct, but I said this one has a negative, so what do we do with that? And we just said negative 5, negative 4, and negative 7, negative 4, and that was our end result for that one. However, look up really quick just to make sure that you understand what we're looking at. Look at the denominator. We have x plus something squared, yes? Look at this new one, though. Does that look like the previous one? No, Mr. Q. All right, so let's graph this one first. So we got y0. X0. And then our points is at 1, 1. There it is. All right, so we got this done. However, this one needs to have a 1 on the numerator, so where do we send the negative to, everyone? To the front. Okay. So, to start off, we have our new equation, g of x equals, bless you, negative 2 with the 1 in the numerator, the negative 3 at the end. However, for those of you that weren't here Friday, look up, or Thursday, my bad, Thursday, this one needs to be factored. So, look at it. Tell your neighbor what to do to factor that one. Very good. 25 and negative 10. What two numbers multiply give me 25, and when you add them give us negative 10? Brandon Darty. Negative 5 and negative 5. And how do we write that underneath? X minus 5 squared. Bam, no hesitation. Let's go. That is correct. So, with that said, tell your neighbor what my new VA is, my new HA, new VA, new HA. Then we'll pass it to Kimberly. Bye. New VA, new HA, Kimberly. X equals 5. And the y? Negative 3, all right? So negative 3 down here. And x equals 5 over here. All right, so far so good. So Jay, where will we... He's not here? Okay. Pass it to Martin. Where will we move these to now that we have our new asymptotes? According to this. I'm saying, according to this, we will move it in which direction? 3 down and 5 to the right. Okay, so 5 to the right, 1, 2, 3, 4, 5. 3 down, 1, 2, 3. So this one here and that one there. So far, so good. However, look up. What does this 2 do to those points? Tell your neighbor, please. What does that 2 do? So Martin, instead of being, look up from here, 1 up, 1 to the right, 1 up, 1 to the left, what should I do? What is it? Right now I'm working with this number. What is it? We're still not with the negative yet. Just the 2. Yeah, 2 up, 1 to the right, 2 up, and 1 to the left. However, the negative does what, everybody, at the end? Flip it. We go 2 steps down. There it is. Hands if you got that. Yeah, we got it, right? All right. So, fairly simple. Move everything to the front, factor the denominator, get your new VA, your HA, and graph. All right? Do this next one by yourself. Completely. Example 3, super duper Q. G of x equals 3 over x squared plus 8x plus 16 plus 2 at the end. I'll give you a head start. Go. All right, what do I do first? Jacob. F of x plus 1 over x squared. So our VA is x equals what? 0. HA equals points. Negative 1 and 1. All right. Not bad, not bad. So far, so good. Now let's go to this one. What do I do? Jacob squared. G of x equals 3. So what do I do to that to get something out here? X plus 4 squared. That is correct. Power Rangers, let's go. So this was 16 and 8. So that means 4 times 4, or 4 plus 4 gives us 8. And there you go. So, not bad, not bad. So what is our new VA? Tell your neighbor, please. Oh, not 0. Tell your neighbor what our new VA and our new HA, and the Jacobs are going to continue with the process. New VA, new HA. All right, Jacob, new VA. Help him out, Jacob squared. Oh, for the Y, yeah. Positive 2 for the Y. And then? Negative 4, that is correct. Ooh, nice save. Let's go. Y equals 2. Okay. So if I was to move the points, look up. If I was to move the points, I would go from here and move it 1 up, 1 to the right, 1 up, 1 to the left, so they can match this, right? However, what do we do with that? What is it? Instead of going one up, one to the right, one up, one to the left, you do what? Yeah, one to the right, three up, and one to the left and three up. That is correct. Let's go. Hands if you got that by yourself. All right, we'll stop right there. Those of you that are following online, make sure you go to the code that was given at the beginning. Do some practice so you guys are ready for the next part for tomorrow. Let's go. Bam. See you guys later. Bye.